Well, thank you very much, Corey, Eric, the whole VCF people for inviting me again this year. I'll try to make you proud. Thank you for everybody for coming. I don't see you, but I guess you're seeing me. Basically, my name is Stefany Allaire. I'm a electronic hardware design engineer by trade, and I'm the creator of the C256 new retro computers. You probably heard about me. I guess it's been almost 4 years that I've been, we're in the 4th year, so I guess I hope you heard about me before. There has been a lot of things that happened over those 3 years and few months. But since last year, I would say since October last year, things started to change drastically in the direction, meaning that before it was a hobby, now it became work because I'm on my own now. And so there's been a lot of stuff changing, direction, and so on and so forth. And this is what we're going to talk about today. So I hope I'm not going to bore you too much with my presentation. It's not like the thing you've done before with the PDP one. It's going to be more like a class, but we'll try to make it interesting. I hope I really going to make it interesting. But anyway, so I don't have a lot of time. I have a lot of stuff to cover. So basically what I want to do is really give you a quick rundown of what happened so far. But instead of giving you the story has been told 1,000 times about how I started the whole thing with David's Murray videos like 3 years ago. And then I started making different products. But I still want to go throughout the different products that were made and what's going to happen in the short terms. I want to talk also about what's going on now. And basically, why am I doing this? After that, what I'm going to do is get you into the process of creating what I've been through to create these products. This is something I've been doing in my career, but now I'm doing it for myself. But one portion of the story will be about the essence of what it takes, or the pitfalls of creating a new product. So basically me giving you some hints about if you want to do it. I'm surely going to make sure that I'm going to discourage you really deeply. So at least if you get into it, you'll be really adamant about you want to do it. And then over time, the concept to finished product section will transform into more like a cautionary tale about, okay, when you're getting yourself into creating products like this, there's a lot of stuff happening and things that you don't think about. So there will probably be a little bit more whining on my part at the end. So bear with me, a little bit more drama, let's put it this way. So I would say the first half will be interesting in terms of, like I said, what's going to be, what is it about to design something and my process to do it. And finally, the second portion will be, okay, what's going on when you actually manage to create something. In the description of the presentation, there was something about VK3, which is the graphic chipset or the FPGA graphic engine that I've designed for the last 3 years. I doubt that we'll have enough time. Certainly, you can look into the presentation of VCS East last year. I talked about it, but if we have time, we'll do it, but I'm not sure if we will. And finally, I'll talk about the roadmap of the awesome stuff that is coming. So let's move on. I said about, okay, I'll come to that point anyway. So, okay, so a quick overview. In April 2018, I got started on the whole C256 Foenix project. It was really a hobby at the time. I was looking forward to do something in the retro world, I guess, and things were starting to get more important. And then David Murray came along, say, hey, I want to have a dream computer. I said, okay, challenge accepted. And then the first few months, I created the C256 Foenix, the first version. And it was always based on the 65816. And I ran it at full speed, which is, well, the speed that that was acceptable for 3.3 volts, I suppose. And the first version that you see on the screen on the left side, I don't know if you see my mouse, but anyway, top left side is really the first version that never came out. That was really the first, brain fart that I had. I said, okay, I want to do it this way. And that's the vision I had for it. Basically, when I went to the Portland Retro Expo that year, this is where I met with David, and I met with other people. And a friend of mine was kind of, okay, you made those choices. Maybe these choices actually are not that great because you got influenced a lot. And at the time I was really green into this, and I was like, okay, if they want this, they want that. And then I really didn't think about the impact of adding all these things in the product. So after coming back from the retro convention, I sat back down. I said, okay, I need to kind of make things better for me and for what I want to target. And I came up with the Revision B2, which was a complete redesign. I scrapped a bunch of stuff. I had new stuff. And I said, you know what? There's this very thin line between what I was doing, and because the backstory was about to create something that was going to be like a virtual follower to the C128 in the timeline of Commodore if Jack didn't left the company. It was like a backstory that I created to make it more interesting for myself. But I realized that, maybe it's not a good idea to kind of follow this trend, considering that the cult of Commodore is very adamant about its history and past. So from the Revision B2 and on, I kind of started to separate myself from this idea. And I started going with the idea that, okay, we need to create something for something new. Ultimately, maybe to create a new era of retro computing. And I will come to that a little bit later. So I created the B2 version. There was some issues with it, but I did manage to make some of them. I found some alpha developers, and they joined in. They got their unit. We started doing some stuff. But that's part of what I'm going to talk about later as well. The idea that I'm a pleaser type person, so I wanted to please everybody, and I start stuffing it with a lot of stuff that was probably not necessary at this point, because most of what I had over time was barely used. But I did come along with the C256 Foenix FMX. There were two versions of them, the C4CB, C4A, C4B, which was, the C4B was really minor changes. Still the same processor, a little bit more memory, and then it was stuffed with Yamaha chipsets like PL3, OPN2, OPM, the PSG, like it's a music machine. There's a MIDI port on it. You can probably read about it or see videos about it. Again, I don't want to spend too much time on this. I made 70 of these units. And I can tell you that as of today, there's probably maybe 15, 20 people using their units. There are in the community using them. So there's a lot of people that bought this unit as a novelty items, I suppose. So that was another lesson learned. It's like, okay, you can make things, but it doesn't mean that people will actually use them. Although I have to admit that, with all the bullshit we've been going through for the last 2 years, well, a year and a half, I suppose, it's understandable that, like life took precedence on having fun on the retro computers. But the FMX was really cool. It was really, it was really the culmination of the 816 platform, but it was very difficult to manufacture. It was very complicated. This idea of to make something look like something in the 80s, because it was also part of my story, was, okay, I could design something and plop a FPGA in the middle of the board and be done with it. But I wanted to make it more interesting. I wanted to look and feel like something was back from the 90s. And that was something I always stuck to. It was really important to me, and it's still very important to me to this day. So, but it required me, because I saw the FPGAs as a Commodore like custom chips, like A6 or stuff like that. Not like it's just a programmable device. You can do like Mr. FPGA and just drop everything you want. I always made sure to design everything around. All the CPUs are real, all the parts are real, because it was very important. So basically the ASIC or the FPGA in that case were really just for the glue logic, obviously the graphic engine, because I wanted to create something, because there was really nothing that was available, and still to this day, there's nothing really available to do that kind of work anyway. If there is anything that exists, it's really, based on PCI Express bus or PCI bus, which is not very easy to interface with. It's a lot of work. Anyway, so built 70 of these. I finished building these, shipped these last year, at the end of the last year. All along, I had this idea to do this user version, like because people are always complaining about, oh, it's too cost, you know, it's very expensive. And to be honest, I don't think the FMX was that much expensive. And then in October, when I lost my job, I started to think, okay, what am I going to do? So I went on and I went on and created the U, which is really a low-cost version of the FMX. There was few things that are not there, but basically that's the, the entry point into the family of the Foenix. Still based on an 816, but now I was more like, I just let go of the idea of to make it look more like a 1990s. If we wanted to have something cheap, I need to kind of integrate everything. And, like any companies that wants to save on their product, they're trying to integrate more and more and more. And I did come up to a price point that was really interesting. But then the shortages of FPGA happened because the U is was based on the Cyclone 10, which is very recent. There's no Cyclone 10 to be bought anywhere, to be found anywhere nowadays. So since I would say springtime, I put on my order of business to redesign the board with a older version of FPGAs. So they're more available, like the Cyclone 4. You can find them in China. They're pretty cheap. So that's part of my redesign effort. But I waited to do it because I want to also change the SRAM. The video RAM is SRAM. I wanted to migrate it to SDRAM, which is a lot cheaper as well. So ultimately, there will be very soon a redesign of the U, which should reduce the cost even more. The board comes as a board. There's no enclosure with it because it does have a significant amount of cost to the unit. So people are complaining about being cheap. You wanted it to be cheap. But they will have cheap. But I have to admit that over time, I realized that it was never really about the money, but really about the value, what people saw in terms of value. And we'll come back to that. But still, I think this is the most interesting version for people who are interested in using the 816 and get into the 816 and get into the whole ecosystem of the Foenix. And people are enjoying the U very much. And so far, it's there's really no complaint on that end. So moving on. So this is coming back September, October, probably October. So it's going to be back in stock and probably, hopefully, more successful because I only made 30 of them. There was a lot of demands for it. I mean, a lot of people wanted to have it. And then when it was available, like people didn't commit. So I don't know why, but anyway, so 30 units were made, basically all the PCBs I had with the Cyclone 10 footprint. And then I hope it will pick up back in fall time. So from all this, what happened from this, like I said, I've learned a lot of things. And then I realized that, okay, the 816 is a great processor. No offense to any Bill, David. I love programming on the processor, but it's still, for the community, it's still a very fringy processor. If people have to choose between the 502 or the 816, I think they're going to go for the 02. So I kind of painted myself in the back, on the corner. I was kind of limited. So I found a way to get me out of there without trashing everything we've done. And that is what the GenX is. And to make it a short story, the GenX is basically an FMX, but with the possibility of adding or to putting a 32-bit CPU module as well, which means that it's a dual CPU system where, like a C128 almost. I say almost because there's a switch in the front that you would have to push to switch from one to the other. They're not running. Right now, they're not running simultaneously at the same time. So the idea was to keep the essence of what we've been working on all this time and to try to expand the offering. So the system is basically, you have the same hardware, but you change the processor. which means that, for example, the kernel, we're writing a kernel in C, so we can port the same kernel to every platform. And right now we're targeting the 68,000 families, the 30, the 40, the Intel as well. So the idea was really to bring a platform where the surrounding is always the same, but the processor can be changed depending what you like. You know, it's really, okay, you like the Motorola, I like the Motorola better, so I go with Motorola. If you like the Intel, then you can have an Intel platform. It's not a PC, although you could probably convert games to it really easily, but it's not a PC. But still, it gives you the chance to go back to working on these processors again. A spin-off of the GenX is the A2560X, which is the 32-bit version only. So there would be no 816 subsystem involved. So it's basically the same thing. The color changes, but there's no switching in between the CPU. So those two things are exactly the same. Just the A2560 would be a little bit cheaper because there's not the, the processor, the 816 processor, the flash, the ROM, so on and so forth. So this is what we have today. This is the plan. There's also the A2560K, which is a keyboard version of the A2560K. I'll talk about that later. So moving on. So this is what happened. So right now, the U is coming back in stock in early fall, and so does the GenX and the 2560 that are still in design at this stage. But things are going very well because most of the system is basically what was designed previously. So there's very little change to be done aside of interfacing 32-bit processor as opposed to 8-bit processors, 8 or 16-bit. So. All right, so what is going on now? So this is what I was talking about. I'm mainly working right now on the whole new system design with the GenX, the A2560X, the A2560K. I have the development board I created that includes all the hardware of the GenX on one single board because the size of the Foenix, the GenX, is 9 by 9 by 9. So it's pretty small. The board is an ITX mini ITX size board. It's compatible, although there's a lot of subassemblies inside. So in order to avoid making mistakes or increasing the possibility of making mistakes over having multiple assemblies, I just I created one board with everything on it, doing the development on it, and then I can, when it's working, finding the problems, I can move on and create spin off all the different assemblies from the original schematic that works. So ultimately, like I said, the GenX, the A2560 have the possibility to change. I mean, the three of these guys have the possibility to change the process, the 32-bit processor. The 2560K, which is probably the most expensive version ever, I was thinking about shipping it just only with the 68040. But still have the capacity to change it with the Intel if somebody wanted it. I also plan to do RISC-V next year and also possibly the MIPS because I can do it. We'll see. That's one of those trip things that if you do it, maybe they will come or not. So this is what I'm working on right now. And from the moment the development board works with the SDRAM, because the GenX have all the SDRAM interface for the video, then I will port that design I created for the GenX back to the U and reduce the cost of the U. All right, so why? So I'm gonna do a little bit of evangelization for about 5 minutes. Why am I doing this? Okay, I had this interview with Bob from Retro RGB, if anybody knows him. Possibly you saw the video this week or last week. And I was talking about why am I doing this? Okay, because the way I see it, and this is really my humble opinion, I'm not trying to provoke anybody. It's really what I feel is that so far in the retro community, what I saw is basically people just rehashing and pipping their systems. And I over time I realized that there's something missing. There's something that is I think that was very important back in the day, 1980s and everything. And the part we're missing, I think, is the part that when we got the Commodore 64, Apple II, all of these retro computers that were just coming every year, there was a new one. We got to learn something new. We got to sit down and try to understand, and we didn't have any tools at all, right? We started from basic and we learned, we read the manual, we got into it, and we we started having games and starting to crack those games, making demos, but we had to spend all these years learning a new machine. And I think we got a lot of, that's what made this generation so into the whole computer thing, because we got offered a chance to learn and to understand something new. And I think the retro computing world in 2021 doesn't have any of that, aside of David's X16, the Amiga 65, all the new retro platforms that came so far have this possibility of getting people to sit down and to create new things. And don't get me wrong, there's nothing wrong, and it's fun to work on Commando, to play Commando on C64, get the music. I get it, I get that, but it gets old after a while, for me at least. So for me was, let's bring a new computer, let's get people to redesign or create new things from scratch. Because you have to admit that at some point we were very dictated into where we were going, right? The corporation were really driving the computing effort to bring those new computers, and then the PC came around, the Mac, and it was a corporate push to get something for them to use. So for me to see it, the way I see it, is like a new chance for us to just create new things, and what I realized also is that I saw people being very lazy. Oh, I'm going to create something, but I'm going to make it look like this. I'm going to make it run like this, because we are so indoctrinated in our ways. So fundamentally, part of the vision of what I'm trying to do, and I'm pushing real hard, I get put a lot of pushback, but fundamentally it's to bring a new era of virtual computing with old processors with limitation, to get people to discover a new machine, to get new creation, new OSs, new file system, new whatever, new demos. I don't know, people doing demos, I don't know, they don't get tired of making them. They know everything about everything. Anyway, so this is my vision. So this is why I'm so obstinate about this. I'm probably, among all those projects that exist, I'm probably the only one to really push this idea that if we wanted to, we could literally create a new era of virtual computing, all like new systems, new software, but it would be our own. It would not be pushed by any other, corporation that wants us to discover, to push for a Windows system or whatever. We could create our own stuff. But anyway, so this is fundamentally or religiously what I'm going for. So let me read my slides so I'm not forgetting anything. Yeah, so retro nostalgia, I think, is better appreciated if and I think this is what we really enjoyed back in the day, was really, we struggled, we got it to work, and we were proud of ourselves, and we were like, okay, let's do something more like it. Let's put a sprite on the screen. And when we got the sprite, okay, let's move it, and then move on and move on. Nowadays, it's like, everybody's so lazy. It's like, oh, I can buy a Raspberry Pi $30, I'm gonna put software, it's gonna run. Oh, there you go, you have an LED that flashes. So it's okay for people that want to do it. I'm not against it. From my perspective, of course, it's like, okay, I think we can push ourselves to do more than that. But anyway, again, that's just my opinion. You don't have to share it. So yeah, I think this is something that really is missing right now. And I think we should, believe in this idea more and go back to it more. I mean, doesn't mean that you'd have to buy my stuff. It's not about me selling my stuff. It's really about, because everybody that got really involved with the Foenix, I got a lot of emails from people saying, wow, it's so great. It's really bringing me back into the past where I was like, and like I said, the times we're going through right now, we need a little bit more of that, like this sensation that, okay, it means something. It's fun. All right, so yeah, so belief is really important. So I'm trying to, let the idea go that, this is something that might be worth the effort, and go back to it. Obviously, I'm trying to sell my own machine, because they do exist and they're selling, not a lot nowadays, but they're selling. They did sell in the past, as opposed to the others. So a little bit of backstab to my competitors that've been doing some vaporwares. Anyway, moving on. Okay, so now that my philosophical talk is done, yeah, so I want to talk to you about, so what time is it? It's 56. Okay, so I need to go quickly. Okay, so how did I go about going to design these things? I would say that early on in the C256, it was David's requirements, which I kind of molded myself and say, okay, this I'm going to do, this I'm not going to do. I was going to pay for the bill anyway. I was going to foot the bill for it. So I said, okay, I'm going to do it my way. And turns out when we met, it's like we didn't agree on where we were going. So I was going there and he was going completely the opposite way. So like I said, this is like the first step and second step are really a guideline for you guys if you want to do it. So it's really, what do you want to do? You have to kind of nail down at first, okay, how I'm going to do it, what I want to do, what I wanted to achieve, which is basically the process you would go to create anything. Yeah, the second step is really about the design, everything you need to get to something that works. And finally, when you got it to work, then what do you do with it? Because this is, when you're actually going from creating something to selling it, there's way more after the creation process. And for any engineering oriented type people, that can be very hard. Let's put it this way, or somebody who's not very business oriented. All right, so let's say, okay, so before we start, we do a sanity check, okay? Because you got to get yourself into this nightmarish time and you ask yourself the questions. Are you insane? And if then the answer is yes, then that's a good start, I guess, because you have to be a little bit insane to get into the process of creating something and possibly selling it in the world of even just the retro community. I figured that every communities and every fields are about the same anyway. Human beings are human beings, no matter where we go. So basically the question you need to ask yourselves, and that's basically, I probably skipped on some of those questions early on. So how much time do you have in your hand to give to this? For me, early on, it was a hobby. So I had my nights, I'm single, so I'm just working at night and working on the weekends. I was making a good salary when I started. So I had monies to spare and, it was fun, right? Yeah, what could possibly go wrong? Are you willing to give up your life as it is, home, work, friend? For me, I just had 2 of these 3, so it was fine. For pain, yes, there's a lot of pain involved in getting into the process of creating something, that's for sure. No doubt about that. I mean, one could say that it's the same thing for any creative endeavor, but this one is particularly painful. So if you're willing to share and sell, yeah, are you strong enough to deal with trolls and ignorance? And because it's a good portion of, I had a hard time dealing with this early on because I was put on the spotlight really quickly and I was not ready for this. And then even last year in 2020, I think I kind of made a video about me giving up, and I really never give up really, but I was really down because of all the complaining and the funny part, it was very few people, but the bullies got me to a certain degree. So this is important as well if you wanted to get, and this is something that I really struggle with. So basically my process when I got into it in terms of concept. So for example, when I got into very early on with David's, said, okay, I would like to have this, that was a great starting point for me. But I took about a month and a half, 2 months to really think it over and say, okay, what am I dealing with? Okay, what is the State 16? How does it work? And even when I did that, I was not completely, it was something completely new. I didn't know what I was getting myself into, but I went into this, I've been doing our electronic hardware design for 30 years now. So hubris, So I got into this, it's going to be easy, 14 megahertz, no problem. So my process is always helped a lot by using a block diagram, how things will be connected, how data will go from one section to the other. So I don't know if we see clearly. So on the left side, this is the block diagram I created when I did the first one. And as you can see, it's very cool. It's very enthusiastic. It's very full of colors, a lot of shadings, a lot of stuff. I was really into it at the time. So that was back in July 2018. And now on the right side, this is the block diagram I did for the manual for the A256. It's very blocky and it's very straightforward, but it does give an idea where things are going and how things are connected together and how it's going to work together. So I think this is a great tool to start with. What you want And in terms of when you're dealing with electronics, you say, okay, how am I going to connect things? What parts do I need? Do I need FPGAs? Do I don't need FPGAs? And then you go from there trying to figure out, okay, if there's ritual parts, you need to figure out and find where I'm going to find them, where I'm going to buy them. Is it going to be DRAM, SRAM? Is it going to be easy? You know, early on, I used SRAM because it was a lot easier to deal with. Later, I use it. Well, now I'm using dynamic RAM, so I need to create this dynamic RAM controller, which is a bit of pain in the butt, but you know, SDRAM is not that bad. So this is really the process of really evaluating everything. Well, again, for me, since I've been doing that for many, many years, it was an easy process, but still, that's why I'm kind of giving you a heads up about the process that if you wanted to get into this, that would be a good way to go. So after you figure this all out, or at least you have a good idea, you've written down your stuff, or you have a good, you know, mental picture of what you want to go with this. So you find your tools, I guess, but that time, if you're willing to get into the process, and that's how I went into this, I had some tools I was using, although I was not using Altium Designer for schematic capture. I transferred my stuff over to Altium later because at the beginning I wanted to be a little bit more open source, but then I realized that, you know, being open source is for hardware is a weird thing. I had my ideas about this. I'm not going to get into this. Oh, I made a mistake there. So yeah, so when you start, you want to have the right tools. Let's say now I'm using Altium Designer. For the mechanical software, I'm using Alibre Design, which is a lower cost version of what the other 3D software, I don't remember the name off the top of my head, but I'm sure you know which one I'm talking about. So first step, create a schematic. You know, at this point, if you're an experienced designer, you get into this, you get your parts, and now that's great because I would say take your parts all from SnapEDA, SumAxis, all these places, they offer these samples for free. But a word to the wise, yeah, don't trust them because sometimes they're wrong. And so this is the first lesson today is assumption is the mother of all fuck ups. So it's really important to understand that. And this is for anybody who's done design before, you should know that rule. It's very straightforward. It's one of those, you know, what's the name of the guy? Never mind. So yeah, assumption is the mother. So don't trust anything, test everything, make sure everything is fine. While you're doing your design, just revise it. This is something I say, this is something I lack sometimes, I don't do, I get lazy. And it comes to bite me in the ass later. So what I did right here, so I mean it, put it the back burner. Yeah, a good rule for doing design, when you design something, when you're done, just put it in the back burner for a few days. Just don't look at it, don't do anything, and then after a week, you go back to it and you find stuff that you would never have saw before. Use all the reference design you can. That's what I did, all the FPGA stuff, because their stuff is working. So this is, take their parts, even if they're more expensive, take their design, use their stuff, you know it works, it's supposed to work. The only thing that would not work is the fact that it's a reference, you didn't lay it out the same way like for switching power supplies or stuff like this. This is really important. So finally, when you're doing your schematic capture, if you're using an FPGA design, here's 3 rules you need to do to make sure that it's going to work. Because if your FPGA doesn't work, you're done. You get your board, you trash it. So decoupling, 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 decoupling. Put great power supplies. Put the money in there. You won't regret it. Invest more money. Clocks, make sure that the clocks are always going in the right pins because they're dedicated pins for them. Clock in, clock out. Keep that in mind. The configuration pins, super duper important. If your configuration connectivity is wrong, you take your board, your beautiful board, you trash it because there's nothing you can do with it. Even more so if you didn't fan out all the BGA paths underneath it. That's another rule. So that's the last rule at the bottom of the page. So we're designing with BGA packages, fan out all the pins all the time. Even it makes you more pain in terms of routing your stuff out. So that should be self-explanatory. So these are, you know, things that I've been doing over the years. But again, the story I'm trying to tell you is that early on, these are the things that people need to do to get better. Hold on a minute. Somebody's communicating with me. I'm just going to say I'm busy. So moving on. Where am I? Okay. So my process when I create something is really, I'm going to create the schematic. I'm going to create the new schematic, and then I'm going to bring my schematic to my PCB design, and I will start placing the components, and I'm start placing the mechanical components first. And then when this is done, I create a 3D model and I bring into my electronic, like mechanical software, and then I start creating the enclosure around it. So this is what I did with the first Foenix, the second one. And usually what I do is I bring the PCB in, like you see an example on the image. I usually place all the major components. I bring it in because there's no point into bringing the small components in the software, mechanical software. It just makes things so much heavier and slower. So it's really about bring the essential, where the connectors, the big parts, everything that's going to be in the way, and you bring it in your software, and you start looking into putting it together. And when you're creating your enclosure, you just start at the bottom part and you go up and up and up, because even if you have a vision of what you want to do, it's never clear or it's never obvious till you actually create all the parts. And that's another rule. Just create all the 3D parts, or find all the 3D models you can. Try to make it as real as possible so you can actually see all the conflicts you'll have with all the parts and so on and so forth. So yeah, trying to find references, images if you don't know where you're going. Some people have visions of clear vision of what they want to do. Some people don't have so much clear vision. So I kind of did the same thing, not so much at the beginning, more later, like the cube, for example. Obviously, this is a recall of what the next computer, the SGI colors. So that was really to honor the idea of what they did in the past. So again, schematic capture is usually the first part I do. Then I bring in the parts. I do a partial placement. I bring in all the major stuff, and I bring in the mechanical software. And at that point, I start doing some 3D printing to see if it fits. I mean, the 3D printed parts fits together. And when it does, then I go back to the electronic. So moving on to the other image here. Let me find my mouse. Okay. So the PCB layout, same thing. When you create your footprints, bring in 3D models. This is a great rule to make sure that there's no conflict or no problems with them. Yeah, double check your footprint. Repeat after me. Assumption is the mother of all fuck-ups. Very important. Never forget this one. Then in my case, I had to do a separation between the video parts and the audio parts. Seems pretty obvious, but use LDOs, create silent power supply rails to make sure I'm not bringing all the noise created by the CPU back to the audio system. So you change your ground, you separate your ground, all these things. I'm not going to get into details. What else? Use the biggest PCB. Yeah, when you create a PCB, make sure that it's always the less amount of layers. The biggest feature you can use. Try to make it easy for yourself. The more layers, the more problems you'll have. I got stuff made in China that's 6 layers, and they fucked it up. And obviously they're cheap. They don't know, they're doing their thing, and sometimes they don't test their thing. They're saying they're going to do the electrical test, but they're not doing it. So this is not cool. So these are the rules, and this is what I went through, and this is what I always go through when I'm creating all these different boards. So, all right, so okay, am I missing one page here? Okay, the design phase, and then when you're done, okay, so when you're done, you got your PCB layout done, you check your stuff, it's gonna fit in your mechanical design, because when you're done, completely done at the end, you basically get a final 3D model, you bring it back in your mechanical design, you make sure everything fits. You're ready to go. You say, hey, I need some parts, because you need to build your things yourself at first. Well, because some people will say, well, you can get these people to build it for you. Yeah, that's true. You can get GLC PCB or the other guys to do it for you, but you're missing a little bit of essence. You know, you've been out putting all this work for all this work to create these boards, but you're disconnecting yourself from it. I personally feel that it's an important part of the process to sit down, buy all the parts at DigiKey, even if you have to bend over backwards because they're charging you an arm and a leg. And I'm not going to talk to you about the rest of the image I was trying to reference to. But basically, buy the parts, even they're more expensive, build the first prototypes at home, because this is how you can, at home, wherever you are, this is how you're going to find your problems. Because if you build it, you remember how you designed it, you put the parts, and this is many, many times I found my problems or potential problems that would going to come around when I was building the boards by putting each component. Prepare all your components beforehand, just put them on a plate or something, just get them out of all the reels and all the trays and put them in front of you. It's a lot faster. Buy some bins, put all your components, separate them, classify them. That saves a lot of time, because opening the bag, getting the strip out, getting the thing takes a long, long time. So, but it's great to do it. I think it's a great process. I've always built my boards by hand, because if you ask somebody else, if they do something with it that it's not right, find a problem with somebody else built your boards in China or whatever. Yeah, it's going to cost you a lot. When purchasing stuff local, if you don't find your local, I mean, nowadays it's kind of obvious that there's a lot of shortages. China, find a good supplier on Alibaba. There's good one. There's really bad ones, really shitty ones, and even worse when you're buying FPGAs, even worse. They're trying to pass you engineering samples and stuff like this. You know, if you can avoid it, don't do it. But if you can find yourself one, ask a lot of people, ask people if they know a good one. I was lucky on one side, I was not lucky on the other so much, but then, you know, you're dealing with what you have. AliExpress is another way to go. AliExpress is more a hit and miss, but if you buy AliExpress, you know what you're getting yourself into. So there's only one person you can blame when you actually buy parts from them. But it's sometimes they do get good parts. I do. What I do nowadays is I buy a little bit parts there, a little bit parts there, you know, different suppliers, the same parts, different suppliers. So at least if I get few that are bad, I didn't put all my eggs in the same basket. So I think it's a great rule. So the PCBs in China, be aware, yeah, they're cheap, GLC PCB. I get my boards made at GLC PCB, which so far has been the cheapest and the best. At least if they're cheap, if they're doing a bad thing, at least I don't feel so guilty about it. My rules with PCBs is the more they advertise, the worse they are. Because if they advertise so much, it's probably because there's a reason. It's the same thing with movies. I don't know if you've noticed, when you're watching, there's a new movies coming out, when it doesn't do very well, you see advertisement everywhere. So this is my, you know, rule of thumbs, that if they do too much advertisement, it's probably not a good place to go. When you're getting your PCB, get a stencil made, use the paste, takes a lot of time, buy a toaster, use a low temperature melting solder paste, makes things very easy, super fun. You don't bother yourself with, you know, raw ass stuff. That's bullshit, please. Yeah, so this is the process I'm telling you about, and this is the process I'm going every single time, every revision. I'm not sending anything to manufacturing in terms of quantity till I got one single board that was built and it works 100%. I don't get my prototypes made by GLC PCB because, first of all, GLC PCB do fabrication now, but they do only one side, which is kind of ridiculous. Anyway, so second portion of all this, when it's built, now you have to put the power on. Yay! So it's cool, it's awesome. So I need to go quicker. I'm gonna run down these really quickly now. Power it on. If it's smoke, well, you know why it's smoked. Some people are careful, some are not that much. I personally just go with it, just connect it, make sure it works. So if you have an FPGA, first thing I do, check the power supply. Power supplies, rails are good. I connect the JTAG, I make sure I can connect it right away, because if it doesn't work, the communication is not good, garbage. The soldering is not good, garbage. Clock, garbage. All these small details on the design for the FPGA. That's why it's so important to make sure that every aspect of the FPGA design, because nowadays there's more and more and more, although there's less and less parts available. But if you're going to do any design with FPGAs, always make sure, always, if you're going to scrap everything else or overview anything else, don't waste your money. Just make sure everything is connected. And if the JTAG works, at least you get working. You can get something working, even if the flash doesn't work. If you fan out all your your pads on your BGAs, you'll be able to save the day as well. So these two things go together. So I'm skipping on this really quickly. So you got it to power on, you check all the rails, you can communicate with FPGA, you're good to go. You can start doing your debugging, your powering up, and I mean, the real development that starts. And that's going to take you a lot of time. And that took me a long time to get the engine, the graphic engine developed and everything. But at that point you can say, okay, everything is going to be all right, because everything else you can fix. Okay, this is really like a no-brainer at this point. So if you have anything else with a lot of BGAs, a lot of pins, a lot of balls, make sure that you can communicate with your stuff, because if you can't, you are screwed. So at that point, you start your development. I did my development, start doing the FPGA design with the different revision of the Foenixes. I got more stuff in there over time. And when I was done, then, well, I ultimately found problems on every board I do. There's very few people I know that got their first board working perfectly. If it didn't fail at the beginning, it probably failed in EMI testing later anyway. So you'll go through many revision. That's part of the process as well. So you go rinse and repeat. You start making your changes, going back, reassembling it, making work again. And that's basically what I went through for all the different revision. And the revision, the FMX before there was C4X. C4A. So that means that I went through C0, C1, C2, C3. I made a lot of revision, and I'm not going to tell you why, because I'm going to upset people. So, all right. So you have to been through all these debugging. You have got it to work. The FPGA design is great. You start to see the light at the end of the tunnel. You have spread the words about, oh, I have this board that's working now. This is going to be great for humanity. And after the moment you start talking about it, then you start having all these negative feedback coming to you, but you push through. You were like, okay, I'm going to make this this work. People want your stuff. And I said, shit, but you know what I'm talking about. So, okay, you have your prototype, you have everything. We're going through the products, production, mass production. And then when I'm saying mass production, I'm talking about like low volume mass production. Unless you're working for Apple, you're not going to sell 1 billion of your stuff right away. Depending on the success of people buying or pre-ordering or anything, you might end up selling 20 or 500. But either way, I mean, 500 usually is less of a problem, but I'm talking about my situation where I have to deal with very small quantity, which is a big problem in itself, because I don't sell enough to mass produce them in very big quantity. And everything at this low volume is very expensive. So that's basically what I'm talking about in the slides, where if you want to get your stuff assembled in China, in my case, I had to ship stuff over there because the FPGA I was using, they didn't have any, or they were charging more. And that's a problem, because you can build your kit, send it over there, you pay for shipping to get it there, through all the problems you have to. They're going to charge you a tooling kit. I'm talking about a serious CM. I'm not talking about a GLC PCB, for example, that usually they ask you to get their stuff from LCSC, which you can find pretty much everything, but there will always be components that you cannot have. In my case, it's a lot of components, you know, because they're all retro old components that they're not selling that. So there was no way for me to actually send my stuff away to do this. So, you know, I said, okay, can I do it locally? Well, no, you're not going to do this locally, because every CM, contract manufacturers, will charge you an arm and a leg to pay for just the tooling to get you installed. So for me, it was like, okay, no, it's not going to work. Early on when I was working at the company I was working to, I used their pick and place machine, which I got them to buy, that I used. Anyway, so that's the best solution. But now I'm not working there anymore, so I have to build all the U's, for example, I have to build by hand, because it's a lot of. If you start calculating the amount of money it costs you to get stuff made externally, if you have to ship stuff overseas, it comes back. You need to pay for duties, shipping. It costs you a fortune. So is it worth it? Well, that's the thing. And that's
there's one more talk for today.
Okay, you're cutting me short.
Participation in the hot auditorium, our very own Colby guys. collection of folks who rescued a bunch of Colby's old Walkmacs and other devices. We'll be talking about those in a panel discussion in the auditorium starting in about 10 minutes, maybe a little.
I'm sorry, they were just making an announcement outside. Are you asking for questions yet?
No. I'm going to do it quickly, 5 minutes. I'm going to skip basically the essence of what I'm trying to say at this point. I'm trying to move on to the, when you did all this, it's been a lot of work. You created a lot of stuff. You went through a lot of hassles to get your stuff made. And that's been my process, because after you got them produced, you build them by hand, you have to test them, ship them. And yeah, after you come back to all this, you have to face another dynamic, which is when you ship them, they charge you also an arm and a leg to ship your stuff everywhere. So the goal of the story, or the message in the story, was I wanted to share with you the struggle of creating these things and how it's a lot of work. And because people are going to dismiss your stuff and say it's too expensive, it's too this, but they usually don't understand the struggle of how it is to actually go in the process of creating these things. You know, I didn't talk about the 3D printing aspect of all this stuff. Putting all these things together, testing it, putting it in the box and ship it is a lot of work. For anybody who created products and shipped products, they know exactly what I'm talking about. So I just wanted to share a little bit my struggle and to give you an idea of what is the process of creating every revision. And I'm still in the middle of creating a new version of this. And ultimately, is that when you're done, you say, hey, do I want to still doing it? For me, yes, I want to keep doing this because there's a lot to be gained from this. And it ties back to the original story about, you know, if you want to get something out of the work you're doing, you need to go through the struggle. And that's really basically what I was trying to say. And to close the whole thing, this is the roadmap. I'm going to let you watch it if you have any question about it. So this is coming this week, this fall time. So the C256U, the 82560X, the GenX, and all the different modules, CPU modules that will come after. So I'm done. Thank you very much, Corey. Bye, everyone. Thank you for your time.